Question 2, practice test 2. 30 students randomly assigned to an experimental group receive an experimental pill that supposedly increases memory. 40 students in a control group do not. After 1 month, both groups are tested on their memory with a memory test. The experimental group has a mean of 84 on the test with an estimated population variance of 16, and the control group has a mean of 80 with an estimated population variance of 25. Does the experimental pill increase memory? Using the 0.05 level, what should the experimenter conclude? So, in this question, the first thing they're asking is, what is the research hypothesis? So we know that it's asking for an increase to see if this pill increases memory. So because of that, we are going to write the experimental pill will increase memory. The null hypothesis would be the opposite of what the research hypothesis is looking for. So in this case, it would be the experimental pill decreases memory or keeps it the same. All right. Next question asks, what is T critical? So to get T critical, like all T criticals, we need the degrees of freedom, tails, and the alpha. In this case, we're going to use degrees of freedom total, which is simply the sum of degrees of freedom 1 and degrees of freedom 2, which is 29 plus 39, which is 68. We know this is a one-tail test because we're looking for an increase in memory, so it's one tail. And we know the alpha level is 0.05. Now, in this case, we're going to use the degrees of freedom of 60 because if you look on your chart, 68 is not a viable option. There is no 68 there. So you will take the value that is above that number. So in this case, 60 is above 68. So we are going to use a degrees of freedom of 60. And if you see that number, it should be 1.671 with a positive in front of it because we're looking for an increase, so it will be positive. Okay, the next step, what I did was I put experimental group on one side, the control group on another side, and what needs to be done in the middle. So I wrote down the mean of each group, 84 and 80, the variance of each group, 16 and 25, and the degrees of freedom of each group, 29 and 39. The first step to get the T critical value is we want to get the pooled variance, which is S squared pooled. You do that by taking the degrees of freedom of group 1 divided by degrees of freedom total times your variance of group 1. Plus, same thing on the other side, degrees of freedom of group 2 over degrees of freedom total times the variance of group 2. I did them as separate entities. I add them together. The pooled variance of these two groups is 21.16. Okay, next we need to get the standard error of the mean difference. Now I labeled that S of M1 and 2, like I told you in class, so no one got confused with the difference word because you're adding in this formula. So the way you do that is you take the square root of that pooled variance over N1 plus the square root of that pooled variance over N2. Everything is over the square root. Add these numbers up. As you can see the steps here, I broke it down step by step. After you do the math, you'll see that it's 0.71 plus 0.53, which equals 1.11. So your standard error for this is 1.11. Now to get the T value, the T obtained value that is, you do mean 1 minus mean 2 over the standard error of the mean difference, or the standard error of the means. And in this case, we get a T of 3.604. And then we do a D test. So Cohen's D is used when we're doing independent samples t-test, and that's simply the mean difference over the square root of the pooled variance. and you get a 0.87. All right, so a 0.87 on Cohen's d, we know that's a large effect size. All right, and we see the T obtained is 3.604. The T critical was 1.671. 3.604 is a lot bigger than 1.671, so we will reject the null hypothesis.